Okay, I just wanted to run through some of the stuff that we've been working on for the UberCam 2.0 release. Part of this deals with the Oculus Rift, which here we have our Oculus Rift DK1.1. This is the Oculus Rift developer kit that came out shortly after they completed their Kickstarter campaign initially, just before they got bought by Facebook. What we've got here is the Oculus Rift connected to standard everyday Windows PC. No big deal. Sorry, it's a little bit dark in here, but you'll get the idea. This is more important. What we've got is basically the Oculus Rift connected to the Windows PC, and the camera inside of our host application, LightWave3d, is moving in perfect synchronization with the Rift as I move it in my hand. So how does this get done? Well, let's quickly walk through what's involved. And it basically comes down to a component that works with the virtual studio tools inside of LightWave. And the way that you access this, if you were to set this up brand new, is you take your camera, and for the motion properties, you hit M, and you get a window that pops up, and it comes up and says, okay, here's the motion properties for the camera. And what we do is we add a modifier that's the virtual studio traits. This is already inside of LightWave. This part's normal. This just basically connects the motion modifier to the virtual studio functionality. So once you've got that, and you double click on the plugin itself, it'll bring up this studio console. And this studio console, you can see that when you get that, you have a thing over here called Edit Nodes. If you hit Edit Nodes, you get another window that comes up. That's your nodal editor. Okay, this is all pretty much standard stuff, but the difference now is that the device, when you go and add a device, I'll just disconnect this other one. When you add the device, you can double click it, and you'll find inside of here the virtual headset manager, which is our plugin, and VR headset. Now, this is made possible by a new headset manager from Liberty3d that deals specifically with the Oculus Rift. In order to get this to work, you just set up the connections, make sure that both of them are enabled, make sure your Rift is turned on and it's all good to go, and hit acquire connections, boom, boom, and close this little window down, and then just take the rotation and put it into the rotation for the camera node. So now what you get is the ability to rotate your Rift and see the movement correspond. Now you can see that my camera in LightWave3d is kind of offset, and the reason for that is because I didn't have the Rift in kind of a similar position. And the way to fix that is we can put our Rift down. Let's say that's straight. Okay, that's straight where we want our world to start, and we can go and hit the device manager, and there's a little window here that pops up called VR headset settings. The pull interval settings is just basically a refresh rate dealing with how often LightWave asks the Oculus Rift driver for an update, and this is an expert user's function. Normally the default is 100 milliseconds. You can reduce that for performance reasons, but for now this is just the default, and we recommend that everybody use this to get started. So let's deal with that headset centering problem. Okay, so as we can see, as I rotate the headset, we want that to be our straight position, but the camera's a little bit offset. Let's just get rid of this window here and hit continue. Hold on a second, because that needs to be continue, because we can't close this window without that. Go back to it. Okay, so let's reset our headset, then hit continue. And you'll notice that the Rift will now start from that initial rotation position. And it works beautifully. So this is an empty scene. Of course, performance is going to be impacted with more stuff that you add in here, but the point here is that you'd be able to look around using the Rift and get a really good idea of what your 3D scene is going to look like. Either you render it out using some of our UberCam technology and get it to appear as a spherical video, or if you're working with a video game engine, you can set up your 3D scenes or your levels inside of Layout first before having to export to a game package such as Unity 3D or the Unreal Developer Kit, so you can get an idea of what this stuff will look like inside of the Rift without actually having to go over to those two different game engines to check it out inside of the Oculus Rift supported tools for those. So now that this is working, There are a couple of other components that we have to do first, but we're very much well on our way to getting those completed, and that deals with how you'll be able to see what you're looking at through the camera on the Rift with the proper distortions applied for the lens, bare lens distortions that we commonly see in Rift videos, as well as a image filter plugin, which is done, that will allow you to hit F9, and that distortion will be applied to your render. So we've got a couple of different tools here that we're going to be talking about in our videos coming up, and we hope to have this thing out very, very shortly, because really this was the big challenge with the head tracking. And I should add that this works on the PC and the Mac for both DK1.1 and Oculus Rift DK2 development kits. As they get closer to the consumer release versions, we'll be continuing to update the plugin to make sure that it works with the latest SDK. And later on, once we deal with a couple of other small things, the positional tracking, so up, down, left, right, will be added, but a lot of people have the DK1 and that only supports rotation. So we've decided to leave it at that, and later on we want to support other headsets, and of course Google Cardboard, and those of course only support rotation. So that's about it for the moment. We're going to be busy testing and completing a new manual, and we will let you know when this thing is available, and it'll be very, very soon. All right, talk to you soon.